All right, so we're now moving on to our next video, which is going to be writing ratios. So now we're going to give you just a scenario, and you're going to have to write a ratio coming up with on yourself. All right, our learning objective today is to students will know how to write a ratio for different scenarios. All right, this video will be really quick. There's only one example that we're going through, and that'll be it. All right, so we talked about ratios, what they are in detail, and then now we're going to go ahead and give you a scenario and say, okay, now write some ratios. All right, that is all we're going to be covering in this video. All right, so for here, we're given all these different coins off to the side, and then we're given these questions to work with. So what I'm going to do is I'm going to write how many quarters I have. So I'm going to count them 1, 2, 3, 4, 5, 6, 7. So I have 7 quarters. Then I'm looking to see, okay, how many pennies do I have? I have 1, 2, 3, 4, 5, 6 pennies. And then I'll do how many dimes I have. I have 1, 2, 3, so I have 3 dimes. All right, so now let's go ahead and answer these questions. It says write the ratio of pennies to quarters. So remember I told you before that A to B, that is important in the order, and the same thing B to A, like that. Yes, they may be explaining the same relationship between the two things, but order matters. And it's really important you guys get in the habit of knowing how the order goes, because when in our next section, when we start answering questions, or maybe not the next section, but in this unit, when we start applying and answering like word problems, you'll need to know exactly how they're written and how you need to set them up. Otherwise, you might mix up and answer the question the incorrect way, right? So we know that we need to go from pennies to quarters. So I'm going to write my ratio like this, P to D, right? So then all I look and say, okay, how many pennies did I have? I had 6. I'm sorry, quarters, not dimes. I don't know why I put D. So it would be P to Q. So I have 6 pennies. And how many quarters do I have? I have 7. So you could write your answer as 6:7. You can write it as 6/7, or you can write it as 6/7. You are always going to see, not always, but the overwhelming majority of the time, you're going to see me write it like this. And the reason is when we write it as a colon, when we go to actually try to solve some of these problems or apply them, you may not realize that we can, like when it's written as a colon, like we can reduce that. We can multiply that. We can add and subtract that because it's written in a way that doesn't look familiar to you. Whereas when we write it as a fraction, well, we know we can multiply fractions. We know we can add fractions. We know we can subtract and divide. So writing it as a fraction puts it in a way for us to visually see, okay, we can still do computational, we can still add, subtract, and all that to this. All right, so that's why you're going to see me write it as a fraction. Okay, the next one says, write the ratio of quarters to dimes. So I know I'm going to go quarters. Actually, let me just go ahead and I'm going to write it like this. So I know I'm going to go quarters to dimes. So now when I go ahead and start filling this in, well, my quarters, I have 7 of them. And my dimes, I have 3. All right, that is our final answer. You could write it as 7:3 or 7-3. And you can also write it as 7-3. Any of those will be acceptable, and any of those will work as full credit. All right, but like I said, I'm going to go ahead and leave it like this or write it as a fraction because when we go through another example soon, you'll see why we need to do that. All right, so one of the things I'm adding here now is the different ways that we can compare ratios. So a ratio is a comparison of two quantities like we learned in the last video. But ratios can be part to part, meaning we can be looking at a specific part of our information. Whereas here, pennies to quarters, these are parts to parts, right? Because a penny is a part of all of the coins that we have, and a quarter is a part of all of the coins that we have. Same thing with quarters to dimes. That is still a part to a part. Whereas here for letter C, it says write the ratio of dimes to the total number of coins. So you see here, this one is clearly, well, now we're a part, and this is a whole, because now we're looking at all of the coins together, right? So we can create these ratios from part to part, we can call it, or it can be part to whole, or like they said, whole to part, this meaning the way that we're writing this relationship. So when I do here, I'm now going to go, okay, well, I'm looking at the ratio of my dimes to all of my coins. So it's easy for me to identify how many dimes I have because we already did that. So we know it's going to be 3. Well, how many coins do I have? What do I need to do with these 3 numbers? In order for me to figure out all of the coins, I need to add them together. So 7 plus 6 plus 3. Well, 7 plus 6 is 13, and 13 plus 3 is 16. So I know that that is going to be 13/16 because we're now looking at all of the coins together. All right. There's one more example I'm going to go through with this. I'm going to erase some of this and write up a new problem just to show you why I leave them as my fractions. All right. And there's this one important thing that I want you guys to go through because I don't want you guys practicing bad habits to begin with. I want you guys doing it the right way from the beginning. All right, so let's go over that last question. All right, so now this is the last question that we're going to go through, and then we're done with this video. So now it says write the ratios of pennies to dimes. So not that you need to know this part, but just remember we're doing part to part in this case, and not part to whole. It's just pointing that out. That's what we're doing. All right, so now we're creating a ratio of pennies to dimes. So let me go ahead and fill this in. Well, we have 6 pennies and we have 3 dimes. When you are writing your ratios, I want you guys to be writing them in its simplest form because as we go through to answer some of these questions in the future, you're going to see writing it in the simplest form is going to be the easiest for us. And then also, you should get in a habit of always simplify your fractions. We have it written as a fraction here, but when you're writing your ratios, I want you guys to write them in its simplest form. So if there's a ratio that can be reduced, we want to reduce it down to what its simplest form can be. So we do it just like we would with a fraction. So we have 6 over 3. Well, can 6 and 3, do they share common factors? Yes, they both share 3. So I can divide both of these by 3. Well, 6 divided by 3 is going to give me 2. And 3 divided by 3 is 1. You must leave your denominator as 1. You cannot just write it as 2. If you just write it as 2, you will not get this correct. Because if you just write it as 2, even though I know the fraction 2 over 1 can be written as 2, this isn't necessarily a fraction, but it's a ratio. So we need to keep that 1 in the denominator because we need to let everyone know that we are actually comparing 2 different numbers here, or 2 different units here. We're comparing our pennies to our dimes. So by just writing the 2 like this and not writing it over 1, we're no longer comparing it to another number. Even though we know that that number is there, since it's written as a ratio, we must keep it written as the fraction of 2 over 1. Right, it's another reason why I want to show this to you, that when we go to reduce, if it reduces to 1 in our denominator, you still need to write it. All right, that is our ratio of pennies to dimes is 2 to 1. So we can write it as 2 over 1 like that. We can write it as 2 to 1, or we can write it as 2 to 1. All right, you would not just write it as just 2. Because it's a ratio and we're comparing the 2 quantities there, we need to keep both of those numbers visible. All right, there is a specific thing that we'll learn later on where we don't have to write it over top of the 1, but that gives it a very specific name. We don't call it a ratio anymore, but we call it a rate. So if we're finding the rate of something, we don't need to write it over the 1 anymore because when we're saying rates, we know it's going to be over 1. So that's something we'll cover in the future. But for right now, anytime it can reduce, you must reduce it. And if it reduces to where you have a 1 in your denominator, you must keep it like that because we need to show that it is a ratio. All right, so there's one more thing that we need to go through in this video that I forgot about, and that's whether or not you can determine if ratios are equivalent. So if you're given this problem, determine if the given ratios are equivalent, 6 to 9 and 10 to 15. The first thing I would highly suggest that you do is rewrite these as fractions. And I'm going to go through a few different ways that you guys can check to see if they're equivalent or not. So we can write them as a fraction. So 6 over 9 and 10 over 15. And this is what I mean about you must be consistent. So since we are going A to B, 6 has to be in our numerator and 10 has to be in our numerator as well. We can't switch them up. And what you can do is try to simplify them. Can 6 over 9 reduce? Yes, they're both divisible by 3. So 6 over 9 reduces to 2 over 3. Can 10 over 15 reduce? Yes, they're both divisible by 5. So 10 over 15 also reduces to 2 over 3. When you write them in its simplest form, if they are equal, then we know that the ratios are equivalent. So yes, this one is in fact equal. Another way you can do this is we can then write the fractions next to each other and we can set them equal. Now, we don't know if they're equal or not, so you might want to put a little question mark above this equal, so that this way you're just not saying that they definitely are. But when you set 2 fractions equal to each other, if they're in fact equal, we can cross multiply and we'll get the same value, meaning that we can multiply the one numerator with the opposite denominator. So we can rewrite it as 6 times 15, and then we're seeing, does it equal the other numerator times the other denominator? So 10 times 9. Well, 6 times 15, so 15 times 6, in case you don't know, 6 times 5 is 30. So we carry a 3. 6 times 1 plus 3 is 90. So 6 times 15 is 90. And 10 times 9 is also 90. So that shows that since those two values are equal to each other, that shows that these ratios are in fact equal as well. So if you have a lot of trouble with reducing, your fractions, then you can simply set them equal to each other, and I'm putting that in quotations even though you can't see me, and cross multiply, meaning you multiply to one numerator with the opposite denominator, and then you do it with the other numerator and the opposite denominator as well. And if our values are the same, then they're always going to be equal. And this is something that we're going to learn how to use later on in the year more effectively, and how to solving equations. So this is something that I would suggest that you guys at least get in a habit of understanding. All right, there's one more question that we're going to go through. All right, so we want to determine, are the ratios of 20 to 30 and 10 to 15 equivalent? Well, we can set them up as fractions and we can write them next to each other. The other way that you can determine as well is look from one of your numbers to the other and say, okay, in order for me to get from 20 to 10, I would have to divide by 2. So then if I divide my other, so 20 to 10, that means the other one would have to stay consistent as well. So we would also have to divide 30 by 2 to give us our other number. So 20 divided by 2 is 10. You see how that works? 30 divided by 2 is 15. We see how that one works as well. So we can do that as well. If we can find a common factor that is going from one of our fractions to the other, and we cannot change it. So we cannot do divided by 2 and then all of a sudden divided by 3 on the bottom, right? And it could also be multiplying. We could do 2 over 3 and we can do 4 over 6. And we can say, are these going to be equal? Well, in order to get from 2 to 4, I can multiply by 2. So that means I must also be able to multiply my denominator by 2 in order for this to work. So we can check as well by reducing. Well, 20 over 30 reduces to 2 over 3. 10 over 15 reduces to 2 over 3. And if we were to go ahead and multiply these, 20 times 15 will give me 300. And 30 times 10 will also give me 300. So it shows that it works in any of these cases. All right. There's one more example I'm going to show you just really quick where it wouldn't work. All right, so for here, we can have 10 over 30 and 20 over 40. So we can check first by saying, okay, 10 times 2 gives me 20. Well, 30 times 2 does not give me 40, so I know it can't work. So right away, that tells me that they're not going to be the same. 10 over 30 reduces to 1 over 3. 20 over 40 reduces to 1/2. They are not the same. If we were to go ahead and cross multiply, 20 times 30 gives me 600, and 10 times 40 gives me 400, and they are not the same. So it shows us that they're not equal. So you can either reduce your fractions, you can cross multiply, or you can figure out what is the common factor to get from one of our fractions to the other. All right, that is it for this video.